So in 6.4, this time they are going to tell you that the opposite angles are congruent. So we already know that opposite sides are congruent. Now in 6.4, they're telling us that the opposite angles are congruent. Okay, so now, just like before, I know that the opposite angles are congruent, so I'm going to mark those. So this one is going to be congruent to this one, because those are my opposites, as well as this one. Now I'm putting 2 marks here, because I don't want to get it confused with the others. So I know this one, since it's got 2, is going to be congruent to this one. So we know about sides, we know about angles now, but we still have 2 more that we've got to talk about. So anybody still looking at 6.4? Before we go to 6.5. Okay, 6.5 is the next one. So in 6.5, so again, I'm going to have another little slanted one here. Okay, so we got 6.5. Now in this one, they're telling me that consecutive angles are supplementary. So what do I mean by consecutive angles? They're telling me that consecutive angles are supplementary. The ones on the same side. So they're telling me that these 2 angles would be supplementary, or these 2 angles. So they're telling me they would be supplementary, which means they would equal what? 180. Okay? So let's write that. So I know that consecutive angles are, make sure it fits. Consecutive angles are supplementary. And we'll put in parentheses here 180 degrees. So, by that means that I'm dealing with these 2, whatever those 2 are. So I'm going to do those 2 there in one color, and I've got these 2. So technically, remember, opposites are congruent. So that's why these 2 are both X. Because opposites are congruent. So these 2 are both X. These 2 are both Y, because they're congruent. So these 2 right here would be the ones that equal 180. And then these 2 would be the ones that equal 180. That's what it's telling me. So we've got a lot lot of information here so far that I'm sure in a second we're going to put to the test. And we still have one more that we got to know. Now, in 6-6, the last one that you're going to get, go ahead and draw a perfect rectangle. So 6-6 is a perfect rectangle. Do not lean it over, do not slant it, don't do anything. It's a perfect rectangle. So here in 6-6, we need a perfect rectangle. So we have a rectangle. Of course, a rectangle, we still have, opposite sides are congruent, opposite angles are congruent. We still know that they're going to add up to 180. But in a rectangle, what is special about these angles?
The right angles.
They're right angles. That's exactly right. When you have a rectangle, not one that's slanted like these, but if you have a perfect rectangle, your angles are perfect 90 degrees. So you got to be careful on these. So in this one, you actually have right angles. And of course, it tells you you have 4 right angles if you have one. I mean, that's common sense. If I have one right angle, then all of them are going to be right angles. Because a rectangle, every angle has to be the same. So I'm going to phrase it the way they did, but that really, I don't know why they did that. Well, I'm going to write it this way. Okay, that's easier to understand. If it has one right angle, then it has 4 right angles. So if you know that your shape has 1, then you know that it should automatically have 4. So any questions, any problems, anything at this point? All that makes sense, right? So we're good. We're not doing another proof. Definitely am not doing that one with this. Okay, they do give you 2 more dealing with diagonals of a parallelogram, so I guess we need to get those in as well. While we're at it, get all the little pieces out of the way so that we can actually start getting into our problem. So I got 2 more real quick, then we're going to actually solve some problems. So this will be 6/7 and 6/8. So 6/7 So on 6, 7, again you have a slanted one, but this one's going to be a little bit taller. So we've got something, and it tells us if we've got the diagonals of a parallelogram bisect each other. So if you got a parallelogram, they're telling you that if you draw two diagonals, one from each side, then of course they're going to bisect each other. So you can see that if I draw this, one from each corner, then they are going to bisect each other. So I'm going to write that. The diagonals of a parallelogram bisect each other. Now, if all of these are drawn perfect, then what it's going to do is it's going to cut each one of those lines in half. So every time it bisects, it should cut that purple or that blue line perfectly in half, if it's drawn exactly the way it's supposed to be. Because bisect means that it's going to be cut perfectly in half. Just like your angle bisector and all that. Remember, it cuts the angles perfectly in half. So remember, bisect means that you have two equal parts. And if I can spell what I'm trying to spell, I'm trying to think of something else. So you have two equal parts here. That's supposed to be U. So what it's going to do is it's going to bisect this in both directions, and it should cut it into two equal parts. Meaning, what I should get is that this piece should be equal to this piece. Like I said, if they're drawn perfect. Now, not all of us are perfect drawers, so that may not look that way, but that's what should happen. This piece should be equal to this piece. And of course, we already know the tops and the bottoms and the two sides are already equal to each other. So I already know that this is equal to this, because that was one of the other ones I was already given. And I already know that this is equal to this. So I have a lot of equal pieces. Now that's only if you have your diagonal. So you got to be very careful when you're doing these. If they're talking about something with diagonals, you got to remember all of this. You already know the sides are congruent based on what I've already told you all ago. Now you know that the two diagonals have been cut in half and are now congruent. So does that make sense? Yes, no, maybe, I don't know. We're going to put it to the test in a minute. So we're going to find out. We got one more before we actually start working. So make sure you do not lose this page. So 6, 8. Last one. Still dealing with diagonals here. So what this one says that two congruent triangles are created by one diagonal. So if I were to draw my diagonal in here. So if I draw my diagonal in either direction, it's not going to matter which direction you draw it in. But if you draw a diagonal from one corner to the other, you should end up with two congruent triangles. Again, they've got to be drawn perfect. And I'm going to admit, I don't draw perfect. I can already tell you that. So, every time you draw this diagonal, it should cut these perfectly in half, forming two congruent triangles. So I'm going to say two congruent triangles are created by one diagonal. So you got two congruent triangles created by one diagonal. So again, it does not matter which direction you go in. But as long as I draw it, I cut it in half. I mean, again, it's just like taking your sandwich, if you made one at home and you cut it diagonally, technically they should be the same. But again, it depends. So any questions about any of these 6 before we actually try to use it? Because now we've got to actually put them to the test and see what we can do with them. Okay. I got a mess everywhere over here. Let's put it all back together in a minute. Okay. So let's try doing some work. So let's say I give you can see it. Okay. So we have our parallelogram. It's going to have two diagonals. So go ahead and draw your diagonals in both directions. So we're going to have diagonals in both directions. So it should look something like this. Now, what they do tell me is I know that this piece, this top blue piece right here, is 3x. So this piece is 3x. The bottom blue piece is 12. Now this piece over here is 8. And the other piece is 4y. That's what I do know right now. And of course, our job is to find the value of x and y. So that's what we want to do, is find x and y. So, using what you already know, what we've already talked about, how are we going to find Okay, what did we find out just a minute ago about diagonals? If you have two diagonals, what do they do to each other? They bisect, which means they do what? They cut them into equal pieces. So that means this blue is equal to this blue. And this piece is equal to this piece. So all you need to do is make two equations. 3x equal to 12 and 4y equal to 8. And then you solve those two equations and you are done. It's going to tell you what x and y equal. Because as long as you know that this piece equals this piece, they are congruent. And as long as you know that this piece equals this piece, then you can set those up as equations. That's all I want you to know. Use what we just talked about to make your own problem. So everybody should be able to say 3x equals 12 and to say 4y equals 8 and solve those two equations. But it all comes back from the point, did you know what I just told you? That diagonals will bisect each other and create two congruent pieces. So again, you got to know that. Okay? So, most of you should be able to tell by looking at them, what did x equal? 4. So if I solve this, I should get x equals 4. If I solve this one, I should get y equals what? 2. But again, I've got to know this part. Okay, let's try another one. So this time, make sure I got it. Draw a rectangle. Doesn't have to be a big one because this one is not a big one. Just a fairly small rectangle. Looks kind of like this. Again, it's got two diagonals. It looks something similar to this. Now what they've told us is that this piece over here is 28. This top piece here has a line on it, and it also tells us that it is 2y. So it has this line on it, so it's going to be congruent to something. We just don't know what yet. So we know this is 28, we know this is 2y, but we also know it's going to be congruent to something in a second. I know this piece down here is 4x. And all this piece has on it is this mark. So again, how am I supposed to solve for x and y? This one doesn't even have a piece on it. So what's it congruent to? This other one. Now again, I put one in different colors, but they're the same thing. They both have one mark. So these two pieces are congruent to each other. So if this is 2y, what's this one? 2y. So this should be 2y. They don't always tell you because we know that they have the same mark. We know that they are congruent. So if they both have one mark, then they both have the same measure. So if this is 2y, that's 2y. Now again, you should be able to set them up and solve. So again, what would be my two equations? What's one of them?
28 equals 2y.
Okay, so I'm going to say 2y equals 28. Now, you should be able to solve that and tell me that y equals what? 14. Now, how do I solve the other one?
2 times 14 is, wait.
You have
4x equals 28.
Okay, now, they didn't tell you what this is, but what do you know that y is?
2.
Y is what?
14.
14, we just found it. So if this is 2y, that's 2 times
14.
14. So this is really
28.
28. So it's really 4x equals 28. So what I really have here is 4x equals 2y. But since we knew what y was, I put in 14. And it now became 4x equals 28. Again, don't always forget about substitution. Don't forget about it. It's always there. All I did was plug back in what I already knew. So then that tells me that x equals what?
7.
X equals 7. So it may look a little bit different, but it's nothing that you can't do. So start with the one that you can solve, which is this one. Since this one had 2 letters, I needed to know the other one first. And then I can plug it back in. Does that make sense? Because again, we've done this. We know how to substitute. Not a trick question. Okay. Okay, let's try another one. Let's say this time you have a little diamond, you have a cat, you have something similar to that. If you can see that. It's this one right here. Can you see that one? The paper's been copied I don't know how many times, so it's a little hard to see. Trying to see if they can get it where they can see it. It's this one. So copy this one onto your paper. That's the one I want. So copy that one onto your paper real quick, because that's the next one we're going to do. We're going to see what we can do with this one. Now you'll notice again it's got 2 letters, so we've got to try and solve this one. One of them should be easy to solve. you should be able to go ahead and do X without me, right? This means yes. Because X, what do I know about this problem? Again, I've got two lines coming from my pieces. So what does it tell me? They are what? They're my diagonals. So I know that they are congruent. So this piece is equal to this piece. So go ahead and do this one. 3x equals 10, that's a given. So 3x equals 10, solve for x. Yes, it's not going to be a whole number. So do not leave it as a repeating decimal, just cut it off and round it to one number after the decimal. That piece should be fine. So you should be fine with that one. So again, most of the time you should be fine with that one. So everybody should have that one. And what did we get? 3.3. Because you should have had 10 divided by 3, and 10 divided by 3 is not going to be a whole number. Now, y was going to be a little bit harder. Because y, you are actually going to have to do something a little bit different. I'm not going to make you actually do y right now, because y, do we remember Pythagorean theorem? That's pretty much what you're going to have to do. Because you are going to have to find y. And we can't do it right now because we have a 30, 60, 90 degree triangle. We don't know anything. All we know right now is this piece. We can't do a whole lot. They don't tell us anything in here pretty much that's useful. So it doesn't really go along with any of the other stuff that we've done. So I'm not going to make you do y right now. Now we may come back to it and do it, later. But as of right now, it does not technically fit into what we're working on right now. It doesn't say, yeah, I know this piece is congruent to this one, but how is that going to help me? I don't know what this is. So it's not going to help. And yeah, I know this is congruent to something else, but how is that going to help? I know that these two were congruent because, again, it cut it in half. It's still not going to help. So we're just going to forego y right now. We may pick it back up a little bit, but right now it's not fitting into the plan that we're working on right now. So as long as I know that, yeah, they are congruent, yes, but I need a little bit more information at this moment to be able to actually solve it. So we're going to bypass y right now temporarily. So don't worry about y. We'll come back to it when we're ready. So any questions? We'll get it, but we're just not going to worry about it right now. Let's see. Let's look at the other side. Okay, let me actually put the picture in here. It's easier. Throwing stuff. Okay. Look at this first one here. If I look at this first one right here, what do I know about this first problem? Okay? And what else do I know?
There's right angle.
It's a right angle, so if it's got one right angle, it's got
4.
4 of them. We learned that. So, how am I going to solve for these two? We just said I got 4 right angles. So this actually equals what?
90.
90 degrees. So say 4y equals 90. This actually equals 90 degrees. So say 3x equals 90. Solve your two problems and you automatically know what your answers are. Because if I have one right angle, every angle in here is 90 degrees. So on your paper right now, you should have 3x equals 90 degrees, 4y equals 90, and you should be solving those two. So I should have 3x equals 90. I should have 4y equals 90. And I should be solving these two. And I should find out easily what those two equal. So x should equal 30. And y is going to come out to be 22.5. So again, all I had to know was what I told you earlier, that if you've got one right angle, every angle is 90 degrees. Wasn't a trick question. Now, look at number 2 here. What do I know here about number 2?
Is it rectangle?
Okay? Now, I've got to find two things. Again, I've got to find x and I've got to find y. Now, x is on the inside. So, what do I know about the inside? It's a right angle again. So, if this is a right angle, 90 degrees, what is this? 90 degrees. So, again, say 6x equals 90. So, I can do that one. I can say 6x equals 90. I can solve it. And I'll know what it equals. So if you work this out, x is going to equal what? X should equal 15. Now, that's on the inside. Now, what about the outside? What do I know about the outside of this figure? What did we learn earlier?
The two opposites.
The opposite sides are congruent. So I know this side is congruent to this side. So that means I'm going to set this equal to this. So you say 8y equals 88. So remember I told you, you got to remember what I told you earlier. All those little, what did we call them? I don't remember what we called them a while ago. Little, I didn't call them a theorem. Properties.
of parallelism.
So you got to remember all those. So in this case, what is y? 11. So if I don't remember that opposite sides are congruent, that if I have one right angle, every angle is 90 degrees, I'm not going to be able to solve some of these. And these are not hard questions. Now, look at number 3. Number 3, easy question. What do I know about number 3?
All the sides are congruent.
All the sides are congruent. So 6x is going to be set equal to what?
12.
12. And 3y is going to be set equal to 12. And then again, all I got to do is solve. Easy, easy, easy question. So if I do that, like I'm supposed to, I should say 6x equals 12, And I should say 3y equals 12. Because every side is equal to 12. So what was x going to equal? X should equal 2. And y should equal 4. Number 4 looks like a fun one. So look at number 4. What do we know about number 4? I don't know anything in this problem as far as a whole number. Number 4, all it tells me is I've got 3y, I've got 6x, and I've got 12x. They don't tell me anything in here other than letters. So what can I use in here? Okay, so you're going to do what? Huh? Now the ones that we did consecutive were these two. We would still be dealing with an x and a y. Now what do I know about opposite angles? They're congruent. So that means this is equal to this, right? Can I substitute this in place of this? Equal, congruent and equal are the same thing. So could I put this in place of this? So now I could say 6x plus 12x equals 180.
Oh, yeah.
Because they're supplementary, remember? Okay, did everybody understand what I just did? Yes, no, maybe, I don't know. If they are diagonal, they are congruent, which means they have the exact same thing. They are equal. So what I did was I substituted this in place of this. So what I can do, wherever I put my paper, instead of me saying, I covered it up. Instead of saying that, what is it, 6x plus 3y equals 180, which is the way it should be because they are consecutive angles. These are consecutive. They're on the same side of my shape. Since I know 3y is congruent to what? 12x. I substituted this in place. They are congruent. They're the exact same thing. So they are equal. So this one came out and this one went in. So it's now 6x plus 12x equals 180. Now it's all the same letter. Now you can solve it. So it would now be 18x equals 180. So x would now be, what? 10. And I only can do that because I know diagonally they are equal. Now, what can I do? Well, I can do one of two things. I can put this back in because I know they've got to be congruent. So I can put this back in there and solve it, because does it not mean that 3y is equal to 12x? If they are congruent, then they are equal, right? So if x is 10, then that's really 120. Can I not just solve that and find out what y equals?